Second type of uh, way of looking at how well the sample represents the population is something called confidence intervals. This is probably the most common one that you'll come across. And basically, a confidence interval, again, is a determination of how well the sample represents the population. The confidence intervals come in lots of different times. Sometimes they're 90%, sometimes they're 95%, sometimes they're 99%. And basically, what we're saying is when we see something like a 95% confidence interval, what we are saying is if we were to take the samples many, many times over and over and over, that 95 times out of 100, that the sample that we're seeing falls within a given range. If it says it's in 99% confident interval, that means that if we're to take multiple samples over and over, 99 times out of 100, the sample would fall within a given range. And to illustrate how this works, we're going to use a document that you should have in the module called Coke and Pepsi. It looks something like this, and I'm going to go through this one as an example, and then I'm going to put one into the discussion thread for you to work through as a group. So let's say that in a given city, for example, Wichita Falls, a survey is made and the question is asked, do you prefer Coke or Pepsi? And because of the way that we do things, we're not going to ask everybody, we're just going to take a sample. Now, our sample says that 60% of the people answer Coke and 40% of the people answer Pepsi. So an estimation is that in this city, Wichita Falls, for example, 60% of people prefer Coke. Now, the first question we ask ourselves, does this mean that 60% of the population in the city prefer Coke? No, not at all. We took a guess of what the city looks like based upon a sample. Wichita Falls, let's say, has 100,000 people. We use 380 of them. There is a chance that had we really asked everybody, that it wouldn't be 60%. We probably missed it by a little bit. There are two questions that need to be asked is in terms of what we'd expect our sample to look like. One is, how confident do you want us to be? In other words, if we were to ask the question again and again and again, how sure do you want us to be? Do you want us to be right 95% of the time, 90% of the time, 99% of the time? And the second question is okay, if you want me to be right 95% of the time, how much room do I have? How much do I have to miss it by? Can I miss it by 5 percentage points, 10 percentage points? So, if the survey that we just went through and just to make the math simple, is based upon 100 persons, you can be 90% confident that the actual proportion of Coke will be somewhere between 52 and 68%. Again, what we're saying is if we took a sample and we said that based upon our sample, 60% of the people like Coke, that's probably not exactly right. But we can be 90% confident that if we did another sample, somewhere between 52% and 68% of people would indicate that they preferred Coke. So what does this look like? Well, when you're reading the documents or the research papers that you'll come across, it will have something like this. "60% of people prefer Coke with a 95% confidence interval of plus or minus 8%. And I don't want that underlined. Now, could we increase how confident we were? In other words, if I was a researcher and I said to you, all right, you did a good job with that, but we have to be more sure. I work for Coca-Cola. We got to know exactly how many people want to have Coke or want to drink Coke. What would we have to do? Well, we can increase our confidence level, but if you want me to be more sure, then you're going to have to give me more room to be sure. So as an example, let's say that we increase this to a 99% confidence interval. Then what I would have to say is that you're going to give me some more room. You're going to have to give me about a 12 percentage point range to be right. So with a 99% confidence interval, I would say that somewhere between 48 and 72% of the people preferred Coke. In other words, the software can be more confident, but you have to give it a wider range to hit. So what does this look like? Well, again, it looks like this. Now we have 60% of the people prefer Coke, and with a 99% confidence interval, we could say if we did this again, it'd be somewhere between 12 percentage points above and 12 percentage points below, which matches this and this. Now, we can get better. We could say, well, what if we took a sample of a larger number of people? Instead of using 100, we used 1,000 people. Now, going back to a 90% confidence interval, I would say that it is somewhere between 57.5% of the people and 62.5% of the people like Coke. With a larger sample and going back to 90% confidence interval, now we can narrow the range. So what does this look like? Now with this 90% confidence interval, but I'm using 1,000 people instead of 100 people, I've narrowed my confidence interval band. So what are you supposed to do and say, okay, now you've got 1,000 people, I want you to be more sure, 99%. What would you suppose would happen? Well, this is what it ends up looking like. When we have a small number, here's our average, here's our confidence interval, here's our range. If you want me to be more sure, have a higher confidence with the same number of people, then you got to give me more room. If you'll give me more people and back off on the confidence interval, I can be more sure. But if you're going to hold me to a higher confidence interval, then you got to give me a little bit more room on it. So you can see it's kind of a give and take of how right do you want me to be. I have to have a little more room to be right with this smaller group. But if you let me have more people and go back to being less sure, I can narrow the range of it. So it's a relationship that goes back and forth between all these. There's going to be a discussion thread doing one like this with ice cream, just to kind of go over it again. But the thing that I want you to remember about this is when you write these out, if the question is asked, well, what does this mean about the confidence interval? What we're saying is if we were to take another sample, we could be 90% sure, or 90% of the time if we took another sample, the parameter would fall within a certain range. If we were to take another sample, the parameter falls within a certain range. There's another document that you need to look at called a confidence interval table. In looking at this table like this, let's say that if I took a sample from the population, I might find that the sample has a mean of 0.52629. And what I want to know is this: does it really represent the population whose mean is 0.5? No, it doesn't. It's pretty close. So my sample mean is 0.52629, and I can be 90% sure that with my sample that I took, that their scores fall somewhere between 0.43959 and 0.61299. But if I were to take another sample, we might get something completely different. Let's say hypothetically we did this over and over again. We did it 20 times. So here's our mean, 0.52629, and the confidence interval is between 0.43 and 0.61. So does this confidence interval contain the population mean of 0.5? Yes, it does. But here's one time that it doesn't. The mean from my sample is 0.63, and my range is 0.58 to 0.68. So this sample does not contain the population mean. That's one time out of 10. Here's another place where it doesn't. That's 2 times out of 10. 2 times out of 10 is 90%. So 90% of the time that I took these samples, my sample mean and the range contained the population parameter. 2 times out of 20, or 10%, it didn't. That's what we mean by confidence intervals. So I'm going to post a discussion thread using the same kind of thing uh, with this document called Confidence Interval Revisited. And I want you to report on everything that you can say about these. And if we did certain things, what do you think would happen to each of those?